To continue eliminating components as possible causes for this problem, I'm looking at the connection and wiring diagrams that are affixed to the side of the heater. We can see there's a pressure switch and a temperature switch, and that they're wired in series with each other. So if either one of them is open, the burner won't light, or if it's lit, it will go out. The temperature switch is normally closed. Unless it gets too hot, it will remain closed. The pressure switch is normally open. It only closes when there's enough vacuum being transmitted to it from the inducer fan. Let's take a look at the vacuum pressure switch. In this shot, I had already removed the 3 retaining screws that hold the vacuum switch in place and wiggled it out of its mounting hole. I had checked both terminals to ground with my meter to determine which one is normally hot and which one becomes energized when the switch closes. I hung my red probe on the non-hot terminal and my black probe to ground. You can hear when I click the power on and see the meter respond. When the power turns on, the meter reads around 67 volts. That appears to be feeding back from the internal control circuitry. Then when you hear the inducer start up, the voltage jumps to 118 volts AC, and it stays at that level. This should be enough confirmation that the vacuum switch is functioning properly.
I've got 4 minutes since it ignited. Five minutes now since it ignited. It's still going. Just went out at 5:45. Basically 5:45.
Okay, so the flame dropped out and we could see that the vacuum switch signal never faltered. The switch is good. After another minute, we see the vacuum switch cycle off and on when the inducer stops and restarts to attempt a retry. The retry fails, and another retry is attempted. If you're wondering what I'm doing behind the meter in this shot, I had actually pulled the temperature sensor out of its mounting hole and left it hanging out of the way. I was testing to see if the exhaust temperature was getting too high. Like maybe that's why the flame was dropping out. That wasn't the case, so I reinstalled the sensor where it belongs. Please never leave a heater unattended with a temperature sensor out of position. That's just looking to cause a disaster.
I shut it off. It's just going to lock out again. Now, what happens if I restart it without letting it cool off?
After another minute, we see the vacuum switch cycle off and on when the inducer stops and restarts to attempt a retry. The retry fails, and another retry is attempted. It actually ignited that time. This problem is annoyingly intermittent. There's something very unstable and inconsistent in the system.
Five minutes. Seven minutes. I think we're onto something here. I have to capture on video what I did. What I did was, there's this temperature sensor on the top of the intake for the blower. I pulled that out of there. 7:27, it just went out. About 7.5. It's possible that it reached its temperature set point, though. I have to check that. Well, we'll see. If it tries to turn back on after it shuts down, then it's not at temperature yet. Still trying to start. It failed to ignite, so I shut it off. That was 7.5 minutes that time. I'll give it a minute and then try it again. I guess that temperature sensor didn't make any difference, so I'll put that back in.
I've already proven it's not the temperature sensor, but here's a blurb on that. Then I'll move on to start considering a valve problem or the controller itself.
The temperature sensor at the top of the heater is located at the back of this inducer fan. And it's right here. It's held into place by just 2 screws. You remove these 2 screws, the sensor just pops right out. Notice that there's vent holes in here, and what that inducer blower is doing is not only is it pulling air up through the center of the water heater, this is the middle here, there's that air column through the middle where the exhaust is drawn up through. The air being pulled in through here cools the exhaust as it's coming through here and through the inducer blower. And that exhaust being cooled is what allows it to be vented through a plastic pipe, PVC pipe. I know from bending PVC conduit that it's around 200 degrees when the conduit becomes flexible. So it's probably around 200 degrees when the plumbing pipe PVC becomes flexible. So that temperature sensor, I believe, keeps it below 180 or 160 degrees, something like that. If there's not enough airflow to keep the exhaust temperature cool enough, this temperature sensor will shut down the water heater. It will shut down the burner. It's a safety feature.
Okay, I think I've proven all of my sensors are good, and my power supply is good, and my fuel supply is good, so what's left? It's time to consider the most expensive component in the system, the gas valve and controller assembly. I have a feeling there's a problem with either the gas valve or the controller. The heater works perfectly until the burner's been lit for 5 to 8 minutes, then it drops out and usually doesn't restart until it's had a few minutes to cool down. That could be an intermittent electrical connection, or electronic component, or solenoid valve coil. I could probably just dive right in and replace it without doing any additional diagnostics. But I'd really prefer to have concrete proof of a particular component that's failing, rather than take a wild-ass guess and use the hope and poke method and start replacing expensive parts in hopes that will fix the problem. So, the only thing remaining that I can access to diagnose a potential problem is the gas valve solenoid coil. So that's what I'm doing next. So how do I go about troubleshooting the gas valve solenoid coil? I've got some tricks up my sleeve.
So one little trick I learned, this is a good tip, is that I can balance this metal machinist scale, it's a pocket scale, on top of this solenoid. When the solenoid turns off, that'll drop off because this is magnetized at the moment. See that? So if I balance it precariously, I'll know when that solenoid turns off because it'll drop off. The scale will drop off when it's released by the magnetism being turned off. So we can watch that happen. Yep, there it went. I had 2.5 on mine. It was about 6.5 minutes and it quit. Starting up again for some reason.
Okay, besides having fun playing with magnets, what does that prove? It proves the solenoid coil is working, as in it turns on and off, because you can actually hold a piece of metal on top of it and feel the magnetic pull. But it also proves that when the flame drops out, it's because the coil turned off, not because something else happened inside the gas valve. Now, is that coil turning off because the controller turned it off? Or is it because the coil heated up and through internal expansion and contraction inside the coil, the circuit is opening and closing as it heats up and cools down? Let's hang a meter on it and find out. Unplug the water heater. So I think the gas solenoid is acting intermittently. That's what I've concluded based on some logic and guesses, but this is going to confirm it. What I'm going to do is cut the 2 wires that energize the solenoid. Insert an easy disconnect into that line, into each line, and then if it happens again, I'll be able to pull it apart, install an amp meter in line, and also read the voltage and when it comes on and off as it happens. So I'm going to cut these, and there's really no polarity, but I'm going to deal with these one at a time so I don't mix them up. Really shouldn't make a difference. Really should not make a difference. I think what's happening is that I sat and watched it run this morning, and I could feel the solenoid click in, but after a little while it started to buzz. I think, and it got hot. I think it's on the way out, and it became intermittent. As it gets hotter, it quits working. Maybe something opens up inside. Here it goes. I keep my hand on the solenoid so I can feel it click in. So I
forgot, the other thing I want to do is measure the resistance on the solenoid. You know what? I can... should be shutting off. I want to measure the resistance on it, and actually I can hook up my meters now and see how it performs. Okay. Let's take a voltage reading. On the solenoid circuit. .8 volts AC. And that's okay. Now I'm going to shut it down by decreasing the set point, the temperature set. Let's just see what we have for ohms on this. Okay, I'm reading 1337 ohms on the gas valve solenoid coil. 1337. So this might be a useful tip. I straighten that thing out with a pair of pliers, and then you can pop the top off here. Just comes off, exposes the coil, and actually frees it up. Uh-oh, it dropped out. But while it's on and energized, you can feel the magnetism. If you try to lift up on it like this, I got my finger under there, just lift up on it, you can feel it pulling. You can feel the magnet pulling. Like right now I can't because it's shut off. Alright, it's going to go through the cycle again. Okay, I've got it reconfigured to read the voltage that's being applied to the coil when it comes on. Back on volts DC. Restart it. The inducer starts up. The igniter starts to glow, and the gas should turn on. Okay, the gas is on, the burner is ignited, and there is stiff resistance when I try to pull this coil off of the gas valve. It is the magnetism is on, so it's really pulling itself back down. Oh, I just popped the flame off. So this is gonna, well, it'll go through its cycle and then reignite.
Okay, it's starting up again. As soon as the circuit is energized for the solenoid, I should feel the magnetism come on. If you're lifting up on this, you can feel it. Just wiggle it up and down like that, you can feel it actually pulling. Lift it up and down. When the magnetism is on, you'll feel the resistance. So I think it already failed. The igniter is off already. I'm going to reset it. I'm cycling the power on the water heater on the switch on the top here. Just turning that off and then back on to get it to try to start again. I turn it back on. And there it goes. The inducer blower is now running. The igniter is glowing. We should see this come on. And I should feel the magnetism in the coil. It tries to come on, but it can't. I think because there's an open circuit. So that's it. It's done right now. I'm going to just turn it off again. Now I have to wait a few minutes until the coil turns up enough to resume activity. Let me see. Let me just change my meter configuration here. Okay, I've got connected to the coil now. Is an ohm meter. And I'm just waiting. When that coil cools off, you can just lift it off and hold it in your hand and so forth. When that coil cools off, the ohms reading will change. It'll be 1400 or something, and then it'll change down to 13 something. Takes a couple minutes to cool off enough to regain its continuity in the circuit. Internally, this is an internal problem in the coil. And it's already been a minute and a half since I hooked up the ohm meter. And there it is. It just came back. And we could see it happen there. In another few seconds it'll be down to 1350 or something like that. It's around 1340 or so, I think is the normal range for these, but 1300 something appears to be when it's operational. 1300 ohms. So that's 100% for sure the problem with this water heater. I need a new solenoid coil. I spent some time searching the internet to try to find a solenoid coil just like that one. I think it's a 48 volt AC coil of certain dimensions and approximately 1300 plus ohms impedance. But I had no luck finding one, so I resorted to finding the entire new replacement valve and controller assembly, which is sold as a single part. I found it at supplyhouse.com, which has never let me down, and it was a very reasonable price.